So friends, till now we have completed, like when we started our course on microcontroller, from that moment we have completed all the instruction sets of microcontroller. We have done programming based on those instructions. We have done ADC interfacing, we have done D2A converter interfacing, we have done how to use the timer counters of these microcontrollers. There are two timers, T0 timer, T1 timer, and there are 4 modes of each timer: mode 0, mode 1, mode 2, mode 3. We have seen how the timers are used, how timer interfacing is done, how timer interrupt routine is being written, and then based on that we have done some programming of different modes of timers, auto reload mode, etc. And then we have started with interfacing part. So in interfacing part, we have covered interfacing of DC motor, we have covered the direction control of DC motor, we have covered speed control of DC motor, we have seen how the acceleration control of DC motor is being done. Then we have done stepper motor interfacing with 8051 microcontroller. In that also we have seen how the principle of a stepper motor controller is there and how direction control and speed control of stepper motor is being done. Now the remaining part in motor interfacing is servo motor interfacing. As you all know that we have, you must be knowing the principle of servo motor. Last class also we have discussed that DC motor moves continuously in forward direction or in reverse direction if you apply the supply accordingly. And stepper motor moves one step. The full step angle may be 1.8 degrees and half step angle may be 0.8 degrees. So one step corresponds to 1.8 degrees. So such type of motors we used in watches, clocks, etc. But when you do robotics applications or when you want to design any artificial organs where you have to move the elbow moves like 90 degrees, plus 90 degrees, it may be minus 90 degrees. So, or maybe the robot may turn right at 90 degrees, left at 90 degrees. So, in such cases, the DC motor and stepper motor will not work. There we have to use servo motor. Now, we'll see the servo motor is having 3 terminals. One is VCC. Its supply can go from 4.8 volts to 6 volts. And it has ground. These 2 terminals are there for providing the supply, and one extra terminal is there which is not there in DC motor, that is signal. So signal, here you have to apply the pulse. The pulse may be of 2 milliseconds wide, the pulse may be of 1.5 milliseconds wide, the pulse may be of 1 milliseconds wide. Why these pulses are there, that we'll see now. So in case of servo motor, depending upon the manufacturer's data sheet, there may be you have to apply the pulse to this signal pin every after 20 milliseconds. If you do not apply the pulse every after 20 milliseconds, this waits for getting the pulse, and as soon as it gets the pulse, it moves either 90 degrees forward or 90 degrees reverse. So different manufacturers have provided the different timings for forward pulse, for reverse pulse, and for neutral position. So more or less they are similar. They match towards 1.5 milliseconds. So if you apply the pulse duration of greater than 1.5 milliseconds, if this is greater than 1.5 milliseconds, then the motor will move forward 90 degrees. So we keep this greater than 1.5 milliseconds. So generally we keep this as 2 milliseconds pulse. If we apply the pulse which is less than 1.5 milliseconds, that means this duration to this particular signal, if it is less than 1.5 milliseconds, then the motor will move 90 degrees reverse. So generally we keep this less than 1.5 milliseconds, means we keep this as 1 milliseconds pulse. And if we apply exactly 1.5 milliseconds pulse to this particular signal, then wherever the servo motor is, if it is left, then it comes to the neutral position by moving one step, 90 degrees step to right. If it is at right position 90 degrees, then by moving one step, that is 90 degrees left, it comes to the neutral position. So by applying 1.5 millisecond pulse means wherever the servo motor is, either it has to take reverse rotation or it has to take forward rotation, but it has to come to the neutral position. So these are the 3 pulses which we have to apply to the servo motor for moving it to the steps forward or reverse. If you want to move 2 steps forward, then you have to apply 2 consequent pulses in sequence, which will be of 2 milliseconds each. If you want to move servo motor twice reverse, each 90 degrees, then you have to apply a pulse of 1 milliseconds consecutively after a gap of 20 milliseconds. So for this, we suppose if we want to interface this and if we want to implement this with the help of 8051 microcontroller, then you have to make the configuration like this. You may use any port. Last time also we have discussed that there is no restriction of using the port, whether it is port 0, port 1, port 2 or port 3. But here we have taken the example that we have used port 3, and because it needs only one signal from microcontroller, we have used, let's say we have taken here example that we are using port 3.0 pin to apply the signal pulse to servo motor. Now you must have noticed in this case that when we were going for interfacing with DC motor and with stepper motor, we were using IC L293D, that is motor driver IC, because the microcontroller pins are not capable of driving those motors, DC motor and stepper motor. But you must be seeing at this place, in case of interfacing servo motor, we have not used any motor driver IC, because the pulse which is given from port 3.0 is sufficient to drive the servo motor, is sufficient to apply the signal to servo motor and to make a movement of servo motor. When we have to differentiate between these motors, when we take the motors from market, then how will we identify? The servo motor comes with electronic circuit inside. There is one electronic circuit and gearbox. So no other motors, DC motor and stepper motor, these motors are plain motors with wires. DC motor is having 2 wires, stepper motor is having either 5 or 6 wires. But when you talk about servo motor, the servo motor comes with one box, that is gearbox, and with electronic circuit. So easily, and 3 wires will be there, one for VCC, one for ground and one for signal. So with the help of this configuration or this kit, you can identify whether it is servo motor, whether it is stepper motor or whether it is DC motor. So we are not using any motor driver IC. Now what we do, just to make it simple, just to make you understand that how we move the servo motor to forward or reverse direction. Let's say we are taking 3 keys, key 1, key 2, key 3, and these keys are connected, let's say, to port 3.4, port 3.5 and port 3.6 correspondingly. Now suppose if this may be kept as forward, this key may be for moving the motor to forward direction, this key may be for moving the motor to reverse direction, and this key may be for making the motor to neutral position. So if you find out the configuration, let's say we are not considering the other port pins. So out of port 3, we have used only port 3.0, so which is output pin for us, and port 3.4, port 3.5, 3.6, these are input pins because keys are connected, and we will identify which key is pressed. Suppose if key 1 is pressed, we have to move the servo motor in forward direction, that is 90 degrees, one step in forward direction. If we press key 2, then we have to move the servo motor to 90 degrees at the left. And if we keep press key 3, which is at port 3.6, then wherever the motor is, we have to get it to the neutral position. So like the configuration, let's say if you want to identify the word which will come when you read port 3 for this particular keys, suppose if key 1 is pressed, that is 1 over here, so your word will be 10 hex. And suppose if key 3.5 is pressed, then your word is 20 hex. And suppose if key 3.6 is pressed, then your word will be 40 hex. So when you read port 3 in accumulator, if you find that if the word is 10, then key 1 is pressed, so you have to move servo motor to forward direction. If you find the word as 20 hex, then that means key 2 is pressed and you have to move the servo motor to reverse direction. And if you find the word which is 40 hex, then wherever the motor is there, it has to come to neutral position. So to move the motor in forward direction, you have to apply a pulse of 2 milliseconds. To move the motor in reverse direction, you have to apply a pulse of 1 milliseconds. And to move the motor to neutral position, you have to apply the pulse width exactly of 1.5 milliseconds duration. So how to implement this with the help of program? Let's say we are reading port 3 in accumulator. So we were discussing about a simple program. Now what we have done, we have taken the contents of port 3 into accumulator. So now accumulator will contain the status of all these particular pins. So what we are doing, we are ending accumulator contents with F0. Why with F0 we are ending? Because F0 stands for all ones over here and all zeros over here. Because we are interested in key status of this particular pins and which will be there, ending with 1 will not change the status of original pins. So we are ending with F0 because either way we are not interested in this particular status for keys. So whatever status we will be getting for this, if port 3.4 is pressed, then ending with F0 will get 1. If it is 0, then ending with 1 will get 0. So to know which key is exactly pressed, we are ending the contents of accumulator with F0. Now we have one instruction which does two jobs. One is comparing the contents of accumulator with the immediate contents, and if they are not equal, then moving to the particular location assigned over here. So what we are doing, we are comparing it with so here we will write accordingly where we have to jump. So what we are doing, we are comparing the contents of accumulator with immediate contents, that is 10 data. So if they are equal, that means key the key which is available at 3.4 is pressed. So when you find this as pressed, then you have to move to the forward routine. But if this is not equal, then you have to check the next key. So which is the next key? The next key is available over here. So what you are doing, again you are checking the contents of accumulator with immediate data 20 hex, and if it is not equal 20 hex, that means 20 hex is the data which is available for, which is meant for the motor direction in reverse and which is meant with the help of key 2. So if this is also not equal, that means key 2 is also not pressed. So you move to the next location. Next one, that is next one will be available over here. So this is next one. So that means first we have checked for key 1. If key 1 is not pressed, then we are checking for key 2. If key 2 is also not pressed, then we are checking for key 3. And if key 3 is also not pressed, if all these 3 are not pressed, then you are jumping to again checking the status of the key. But suppose if you find that any of the key is pressed, then you have to move to that particular routine. So suppose if you find that key 1 is pressed, then you have to jump to the routine which is labeled as, let's say, forward, because motor has to, when key 1 is pressed, that means motor has to move to forward direction. And if motor has to move to forward direction, then how much duration of the pulse should be there? For forward direction, it should be 2 milliseconds. So what we'll do, we will use the efficient use of set B instruction, because here we are not using any other port pins of port 3. We are not using port 3.1, 3.2, 3.3, and only port 3.0 is used for signal. So instead of using the whole port move P3 comma something, instead of using that instruction, we are using the instruction set B. Now set B means which bit we are setting. We are setting the bit 3.0. Why we are setting the bit 3.0? Because we have to apply a logic 1 pulse over this particular pin. So, and for how much duration it should be set, or it should be at logic 1. If you are moving for forward direction, then you have to make a delay of 2 milliseconds. I have written the name of this particular delay as 2, just to identify that this delay is of 2 milliseconds. And then S jump again 2, because 1 pulse is applied, so you have to again move to the reading of the status of this key. Whether the same key is pressed, then again you have to apply the pulse of 2 milliseconds. Otherwise, you have to keep on checking which key is pressed, whether it is key 1, key 2 or key 3. But if this is not for the forward direction, then if it is for reverse direction, then also you have to set the port 3.0 pin, but now it will be for duration 1.5. Sorry, reverse means it will be for duration 1 millisecond. So here the delay will be delay 1. The other routine will be there, which corresponds to delay routine of 1 milliseconds. So this will be applicable for the reverse direction. When we talk about reverse direction, then your program will be set B 3.0, because either it is forward or reverse, you have to set this pulse to logic 1. But this logic 1 should be available for the period which is meant for forward, reverse and neutral. So if I write the delay for 1 milliseconds, then the motor will move in reverse direction 90 degrees to reverse direction. Again we will go for checking the status of the keys. And suppose if you want to move the motor to neutral position, then which key you will find pressed? Your key which is attached to port 3.6 pin will be pressed. And if you find that if this key is pressed, then wherever the motor is, whether it is in forward direction, whether it is in reverse direction, it has to come to the neutral position. So for that you have to apply the pulse of exactly 1.5 milliseconds. So you will write the program which is for neutral, which is telling you that you have to set the bit 3.0 and you have to call the delay routine of 1.5 milliseconds to make the motor to come to the neutral position, and then again you go for checking the keys. So three different programs you will be writing. For forward, the delay will be for 2 milliseconds. For reverse, the delay will be for 1 milliseconds. And for neutral, the delay will be for 1.5 milliseconds. We next time when we will see the interfacing of keys and displays etc., that time we will see the configuration. We will try to see how the debouncing of keys are done, how do we write the program to read the key status, and once we go with that particular thing, then again you will rewrite this program. But now this is to understand you that to move the servo motor either in forward direction, reverse direction, neutral direction, you have to apply the pulses of 2 milliseconds, 1 millisecond and 1.5 milliseconds. So I think this is clear to you. I think the principle or the operation of servo motor or interfacing of servo motor with 8051 microcontroller is clear to you. When we go to the next, when we will see the next class, whenever we will see key interfacing, display interfacing, we will see how the keys are debounced with software or with hardware, and how we read the status of these keys, and how we use the displays with 8051 microcontroller. So I think this is for servo motor. You can write your own program to continuously find out whether the motor should move in forward direction, reverse direction or neutral direction. So stay home, stay connected with this YouTube video sessions, stay safe, and whatever your doubts are there, we will continue in our Zoom class, which we will be continuing in next session. So goodbye then.